In today's session, we will be discussing the intersection of a line and a quadratic curve. Since we are talking about a quadratic curve or function or equation, then it means that the curve would be a parabola, and the intersection of the line with this parabola could be of three types. Uh, the first situation could be that the line cuts the parabola at two different points. So uh, it means that there would be 2 points of intersection, distinct point of intersection. The second situation could be that the line might be a tangent to the curve. So if it is a tangent, then obviously it is going to cut that line at a single point, and we will get 1 point of intersection. And similarly, there could be a third situation that the line does not intersect the curve at all. So it means that we are not going to get any points of intersection when we are solving them simultaneously. So if we are provided with an equation, a quadratic equation, and then a linear equation, and we try to find out how many points of intersection are they going to have, then we can find out this thing using the discriminant also. So for example, we replace y in the equation of the curve, and we get a quadratic equation in x, and then we try to find out how many values of x are going to be and what sort of roots are we going to get from that quadratic equation. So if the discriminant of the quadratic equation is greater than 0, then it means that two distinct real roots would be obtained. And the geometrical interpretation of this situation would be that there are two distinct points of intersection. Similarly, if the discriminant becomes equal to 0, then it means that there are two equal real roots or repeated roots. So only 1 point of intersection would be obtained, and that means that the line would be a tangent to the curve. And the third situation could be that we get the answer of the discriminant less than 0. So it would mean that there are no real roots, and consequently there are no points of intersection also. So to further demonstrate this concept, let me solve some examples. In this first example, the question says that find the value of k for which this linear equation is a tangent to this curve. And the equation of the curve is a quadratic one, so obviously it is going to be a parabola. Now we have to find the value of k. So the first thing that I'm going to do is that I'm going to replace this y from line in the equation of the curve. And the equation of curve is y is equal to x square plus 5x plus 2. So in place of y, I'm writing x plus k, which is equal to x square plus 5x plus 2. It becomes x square plus 5x plus 2 minus x minus k is equal to 0. And the quadratic equation we get is x square plus 4x plus 2 minus k is equal to 0. Now we would be working on the discriminant here. So I'm writing comparing it with the standard quadratic equation, which is ax square plus bx plus c is equal to 0, where a is not equal to 0. And we get the value of a as 1, the value of b as 4, and the value of c as 2 minus k. Now the questions tell us that this line is a tangent to the curve. So if it is a tangent to the curve, then the answer of the discriminant must be equal to 0. So I'm writing b square minus 4ac would be equal to 0 because there should be equal and repeated real roots. So b means we will be replacing b as 4 square minus 4 into 1, and c is 2 minus k is equal to 0. we get 16 minus 4 times 2 minus k is equal to 0. In the next step, we get minus 8 plus 4k is equal to 0. So 4k is equal to minus 8. So the value of k in this situation should be k equal to minus 2. So this is how we use this information, that the line is a tangent to the curve. If it is a tangent to the curve, then for example, we have a curve like this, then the line would be touching the curve at a single point only. So it would be a tangent on the curve. And if it is a tangent on the curve, then their simultaneous solution will give us only one root or one point of intersection. And one point of intersection on one root is indicated by this situation when the discriminant is taken to be equal to 0.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.